It says that a staff of 20 teachers, in a staff of 20 teachers, a survey was conducted to establish how many drink coffee and how many drink tea. The following was found. 3 staff members did not drink either coffee or tea. 11 drank coffee and 8 drank tea. So you're supposed to represent that information on a Venn diagram. Now, unfortunately for this question here, we are not told how many drank both of them. Okay, so we have been instructed here to say, let the number of staff members who drink both coffee and tea be what? Be X. So our Venn diagram let me make it a little bit clearer. Okay, so we've got our sample space there. Then our 2 events, let coffee be C and tea be T. So this will be tea and that will be coffee. Now, first thing we have to deal with, in this case here, we can start eliminating what's not common to both. So there were 3 staff members who don't drink either coffee or tea. So those 3, let me put them outside. Then those who drink both, that's X. Now, according to the question, 11 drank coffee. Okay. Now, among those 11, we also have this X here. So, if you want to know those who drank coffee only, sorry, girls, you need to make sure this. You will be part of the lesson. This was homework which was supposed to have been done on it. So, this is 11 minus X. Okay, because this X here, some of them they drink coffee. So, want to know how many drink coffee only. That would be 11 minus X. Then the 8, they drank tea, so that would be 8 minus X. Okay? So those 8, among them, there are some who also drink coffee. And the number of those who drink coffee is X. Okay? So this X here, the reason why we have to subtract here is to avoid what I told you last week, which is double counting. Okay, so this is the Venn diagram. Right? So if you did the homework, you must mark your way, you should have this. If you did your homework, you should have this Venn diagram. Alright? So that's 4.1. Then please take note, this will be the answer for 4.1. So your Venn diagram has to be in terms of X. Then 4.2 now, we have to solve for X. Okay? Now, in order to solve for X, that's 4.2, we have to write an equation in terms of X. Now, there are 2 ways of writing the equation. We can add the 11 minus X plus 8 minus X plus 3. The total is 20. Or you can just eliminate these 3 and add 1, 2, 3. They should give you 70. So you can choose which way you prefer. Right, so I'm going to add all of them. So I'm going to write one long equation. So that equation is going to be 11 minus X plus 8 minus X plus 3. They should give me 20. Remember, this is probability. No negative answers. You can't get a negative answer for X. The answer for X has to be a positive. So, if we do simple elimination, those 2 will cancel out. Right, so we end up getting 11 plus 8 plus 3. So that will give me 22 minus x is equal to 20. So x is going to be a 2. So x is 2. Are you following that? Right? So x is 2. So I answered that. Once we find x, it's always better to redraw the Venn diagram after, okay, without x now. Okay, so I'm going to redraw the Venn diagram without x. So when there is x here, I'll put the exact value for x, which is a 2. So let's move on to the next page. So next page, I'm going to redraw the Venn diagram. So we still have our sample space there. Then our 2 events. So we have T, and then we've got C. Now I can put 2 there. Then 11 minus 2 will give me 9. 8 minus 2 will give me 6. And I've got the 3 outside. Alright? Then 4.3 now, that's where I am. If a staff member is chosen at random, or rather randomly, calculate the probability that he or she drinks only coffee. Okay? So let's answer at the top. So we have got 4.3b. So it will be P. Now, if it's only coffee, it will be P only C, or you can say C only. Okay? So here I will say P only C. Now, that will be 9 over 20. Okay, no, it's not necessary to simplify. Yes.
If you just say PC,
That's not correct now. PC and PC only, they are different. If you say PC, you're also including the 2. So you have to distinguish between C only and C. That's very, very important. 4.38, sorry. 4.38. This is 4.38. Okay. P only coffee. Okay. You can't put P, then you put C in brackets. The meaning is not the same. So P only C and P C, they are totally different events. Okay. Then B, we have P only T, so this will be P P only T. So that will be 6 over 20. Now 6 over 20, fortunately, can be simplified to 3 over 10. But there is no need to convert those common fractions to decimals. Please, that's not necessary. You'll be wasting time. The few seconds that you'll be writing the same answer as a decimal, it's the same. They are common fractions, they are decimal fractions. So if you've got an answer like that, there's no need to convert. Yes, sir.
So is there like a symbol that you can use instead of writing the word on?
No. At this stage, no. When you are dealing with many events, it's just the best way, just follow what the question defines. I've defined in terms of symbols my coffee as a C. So the first event, P only C, is P only coffee. The second one is P only T, because I have said T stands for that plant which we put in our hot water. Okay. All right. Okay, and then C Now C, it says coffee and tea. Okay? So this will be C and T. Now that's the intersection. Can you stop it? It's not part of your curriculum. It's not, what can I say? I'm not going to use that because I don't want to confuse anybody. I want to use and for the intersection or for the union. Okay, because the set theory is not part of your curriculum. Okay, you don't do the set theory. It's not part of your curriculum work. But later after high school, if you start methods for science, that's when you can encounter it. Okay, so this will be equal to 2 over 20, which is 1 over 10. The question does not say we must simplify our answer. So if you write 2 over 20, it's correct. It has to be marked correct. Okay, unless if the question says leave your answer in simplest what? Form. But I'm writing them in simplest form. But decimals are not necessary. Then D now says coffee or tea. Okay? Now this one is interesting now. Okay, I'm gonna give you a rule for this one. There's a rule, even that one too, there's a rule that you can use to calculate it. That is C and what? And D. So I'm gonna derive that rule after this. Okay, so D now. So we want those who drink coffee or tea. Okay? Those who drink coffee or tea. Please be aware that when you say drink coffee or tea, we have got 3 possibilities. We have those who drink coffee only. Then those who drink tea only. Plus those who drink both coffee and what? And tea. Remember I told you that the word or in probability means what? And. Okay? The word or means what? And. So, the answer for this is going to be, I'm going to write it from the basics. It will be 9 plus 2 plus 6. So this will be 9 plus 2 plus 6. This is all over 20. Please just remember that our total in our sample space is 20. Okay? So this will give me 70 over 20. Okay? So that will be the answer. You should smile as long as your answer is below 1. You should be happy. At the moment the numerator becomes greater than the denominator, we are no longer in probability. Okay. Any question? Any question? Right, if you don't have a question, then allow me to just derive I think I'm supposed to do it next. Well, okay, let me talk about mutually exclusive events, then I'll come to the derivation later on. Okay, the next aspect is mutually exclusive events. Alright, it's important for you to know that there are different types of events, but your curriculum focuses more on